Hello, everybody. This is Mr. Tam back with another episode of Secondary 4 CST and Science Option Math. Now, this particular topic is one that can be used by anybody, in fact. It's actually one of the most useful topics that we learn in mathematics, and this is trigonometry. Basically describing the relationship between all three sides of the triangle, and we're going to start with the easiest type, of course, the right-angled triangle. So, let's start off by drawing a triangle. So what this states is that also it has to have a right angle within it. So as you can see here, there's my right angle, and I will now label every side accordingly. So I'm going to label angle A here, angle B here, and angle C here. Now what's very important in terms of notation for a triangle, we always use a capital letter to represent the angles, and we use a small case letter to represent the sides of a triangle. So sides of a triangle can be determined by the angles. So let's say I'm talking about this angle right here, angle A, the side that directly across from it, which is right here, would be labeled little a. Much like this side here, B, could be labeled the hypotenuse, or small b, and C is the bottom. So trigonometry basically states the relationship between two sides of a triangle. Okay, we have three relationships that you guys are responsible for. One of which is we call sine, the other of which we call cosine, and the third we call tangent. Now, sine, cosine, and tangent, if I had to write this out every time, I wouldn't have it. So I would prefer to simplify it, and we drop certain letters. So typically you'll see sine written as sin, cosine written as cos, and tangent written as tan. That being said, having these three relationships, I now have to determine which sides they represent. So let's take our angle A, for example. So first I'm going to write out sine or sin of A, and now I'm going to determine the relationships of each one. So before I go ahead and do that, at the top here, I'm going to write out the relationships for you. I'm going to label every side relative to A. So if A was the angle I was interested in, I would essentially be calling side A the opposite side from angle A. I would be calling the side next to A the side adjacent to A. And last but not least, the longest side, and this never changes, we're going to call it the hypotenuse. So sine represents the opposite side divided by the hypotenuse. Cosine represents the adjacent divided by the hypotenuse. And tangent represents opposite divided by adjacent. So that being said, we're now going to use our letters that we've labeled to write out the relationship for sine A specifically. So for sine A, we know it's opposite over hypotenuse, which means that we have A divided by B. Much like for cosine, we have adjacent over hypotenuse. So cos of A is C divided by B. And if I wanted to write out a relationship for A in terms of tan, it would be opposite, which would be A divided by C. So sine A, cosine A, and tangent A are now expressed in terms of the small case letters. However, this is not always the case. What if I had elected not to choose angle A, but opted instead to start with angle C? Oh, interesting. So I'm going to use the green to represent C and to indicate that it is a different angle from A. So what does sine look like in terms of C? Well, in this case, no longer is side A opposite from C, but rather side A is next to C. So in green, I'm going to put in adjacent. Much like for side C, I'm going to put in opposite, and lucky us, the hypotenuse never changes. So sine of C is opposite, which is letter C in this case, divided by the hypotenuse, which is letter B. Cosine of C is the adjacent, which is side A, and the hypotenuse is B. Much like tan of C is the opposite, which is side C, relative to the adjacent, which is side A. Now, that being said, let's try to do some specific examples about trigonometry. So you really run into essentially both or two types of questions when you're dealing with right angle triangles. So you'll notice I haven't written anything for B, and that's because we never really use we never really use the trig ratios for the right angle triangle. We only care about the angles that are what we call acute, or less than 90 degrees. So if I were to draw a triangle for you guys, let's do this in, I'm feeling a little red today. Okay, and what you have here is 90 degrees. And I'm going to label this side as Y and label this side as X, with my hypotenuse being 20 and my angle here being 30 degrees. So I would like to find, let's start with side X. Okay, so we're going to say side X. So to find side X, you have to ask yourself, well, what's the angle that I'm given? I'm given 30 here. So if I wanted to find side X, I want to ask myself, side X is relative to 30, the opposite side. And the other side that I'm actually given is 20, which happens to be my hypotenuse. So sine is the one I'm going to use because it is opposite over hypotenuse. So sine of 30 is equal to the unknown x, which is the opposite, divided by my hypotenuse, in this case is 20. So this is where you would require your calculator. And when you punch into your calculator, you have to make sure that your calculator says D, E, G, or just the letter D, which represents degrees. Because if you don't have it in degrees, your answer may not be the one that you are looking for, because the calculator will also express things in rad or grad. So make sure it is in degrees. So sine of 30 ends up actually giving me a nice number here of 0.5. And this, of course, is x over 20 still. When I go to cross multiply this, my x ends up being 20 times 0.5, which happens to be 10. So I know my side 10 here represents the opposite side. Now, that being said, you could totally use Pythagoras' theorem in this case to figure out the missing side y, but we're going to try to use trig to do that, and our angle 30. So side y, if I look at y, it's actually the side that's adjacent to 30, which means that since I'm given adjacent and hypotenuse, well, now I'm dealing with cosine. So here I have cosine 30 is equal to the side adjacent to it, which is my y, and 20, which is my hypotenuse. So again, there's a relationship here. Cos of 30 is approximately 0.866. I punch it into my calculator. For those of you in the know, it's actually square root 3 over 2. When you cross multiply this, of course, y ends up being 20 times 0.866, which is approximately, because, and I say approximately because I had to round, 17.32. So that's how you find missing sides if I give you one side and an angle. But you're saying, sir, that's not going to be every type of scenario. And you're absolutely right. Certain scenarios dictate that I'm going to be given two sides and I'm going to find one missing angle. So let's try that question out. Now, let me just erase the bottom here for you guys so that we have room for another quick little question while having all our formulas above us. So, perfect. Oh, let's get rid of the degrees as well. So another question here. Let's have a right angle triangle drawn like this, where I have my 90 degrees here. And I have side A and 10. Angle A, that was angle A, sorry, and 8. So because I'm only interested in finding out what angle A is, I don't bother labeling everything else. Okay, what I will label though is the side that's across from A is opposite relative to A, and for 8, it is adjacent to A. So I look at my relationships and I say, man, that looks awfully familiar. It really does look like tangent. So tan of angle A is equal to the opposite, which is 10, divided by the adjacent, which is 8. So this actually gives me tan A is equal to not approximately, but exactly 1.2, if I'm not mistaken. Give me a sec, guys. I'm just going to divide this. 10 divided by 8 is 1.25. So 1.25, tan of A is equal to 1.25. So the missing variable in this case is not super obvious, but there is a letter that I don't know, and that's angle A, which is basically what I'm looking for. So I want to teach you guys a little trick here that you will need to be able to solve these. Your calculator, I mean, typically when you isolate something, you look at a number, and let's say it's 5x here, and then I have 10 on this side. So typically what you'll do is divide both sides by the coefficient that's next to the x, therefore getting rid of it and leaving you with an x. But I want to divide by 10 because A is what I'm looking for. Unfortunately, our calculators don't actually understand what that means, which leads me to a special button that you're going to need in your calculator. And typically, it is found on top of your sine, cosine, and tangent buttons. And this is the inverse button. So you'll see it as sine to the -1. So sine to the -1, cosine to the -1, or tan to the -1. So basically, to get rid of or divide both sides by tan, this is basically what you want to do. You instead opt to, on your calculator, do tan to the -1 of the value that you're looking for. Here, tan to the -1 of 1.25. So that's what we're going to do. I'm going to take 1.25. I'm going to input it into my calculator with tan to the -1. And I end up with approximately 51.3 degrees as my final answer, which is pretty reflective of my drawing here. And of course, because you guys know that all the angles inside a triangle have to add up to 180, I can very easily find out the other missing angle. So this is where we'll stop, guys. I hope this little tutorial has helped you guys out. Make sure to stay safe in these troubled times. Take care of you and your family, and I hope they are well. And I will see all of you in the next episode. Au revoir, arrivederci, bye-bye.